Dear students, welcome to my YouTube channel Unique Physics by H.J. Sir, 12th Physics, chapter number 1. In last video of this chapter, we explained continuous charge distribution. Okay, and there are three types of continuous charge distribution: linear charge distribution, surface charge distribution, and volume charge distribution. In this video, we are going to explain most important question of this chapter: obtain equation of Gauss law. Okay, so what is use of Gauss law? Generally, Gauss law is used to find electric field produced by symmetric distribution of charges. Okay, and here we have standard question: obtain equation of Gauss law. This is the figure of this question. So first of all, here we consider a conducting sphere. Okay, and at the center of sphere, here we consider small q charge. This is our positive charge. Okay, so for positive charge, electric field vectors are radially outward. Now here we divide the sphere into small area element. Here we have one such area element, and area element is denoted by delta S. Area element is vector quantity. Okay, that's why we use symbol vector delta S. So description of figure: as shown in figure, consider plus q charge at the center of sphere. So this is sphere, this is the center of sphere. Here we consider plus q charge at the center of sphere of a radius small r. The radius of sphere is small r. Now divide the sphere into small area elements. Okay, this is the sphere, and here we divide this sphere into large number of small area element. Such one area element is given, and it is denoted by vector delta S. Remember this point: this is positive charge, so electric field is radially outward, and area element, okay, area element is also radially outward, means both are in same direction, so angle between them is 0. Now here we will use equation of electric flux passing through the small area element vector delta S. So this is our small area element, and here we consider electric flux passing through this area element. Okay, this small circle, it is given by delta phi is equals to, this is our equation of electric flux. Okay, already we discussed this equation in our question of electric flux. So delta phi is equals to vector E dot vector delta S. This is our dot product. Remove dot product, so we can write E delta S cos theta. Okay, here theta means angle. See this figure very carefully. Vector E and vector delta S both are in same direction, so angle between them is 0 degree. Therefore here we have cos function. So cos theta is equals to cos 0 is equals to 1. Cos 0 degree, okay, is equals to 1. So we have equation of delta phi. So this step becomes 1. So delta phi is equals to E into delta S. Here we have small q charge and distance small r. So equation of electric field produced by this charge at smaller distance is given by kq upon r square. Okay, this is our equation of electric field due to point charge. So E is equals to kq upon r square. So use this equation in equation of delta phi. So delta phi is equals to, we can write kq upon r square into delta S. Okay, instead of E, here we use kq upon r square. Now delta phi represents small flux or flux passing through the small area element, but here we want total flux. So total electric flux passing through the whole sphere is given by, So here we want a total flux phi is equals to, we consider sigma of delta phi, okay, summation of delta phi. So total flux phi is equals to summation of delta phi. So phi is equals to sigma delta phi. Sigma as it is, delta phi means this equation. So sigma, here we have kq upon r square into delta s, okay. Here kq upon r square, electric field produced by this charge, small q charge, is constant, okay. So phi is equals to, we can write kq upon r square, and here we have sigma of delta s, sigma delta s. But sigma delta s, this is nothing but total area of sphere, okay. Delta s represent area of small region, okay, or area of element. But here we have sigma, the sigma represent total area of sphere, and it is given by 4 pi r square. So instead of sigma delta s, we use 4 pi r square. So phi is equals to kq upon r square into 4 pi r square, okay. But here we want our equation in terms of q only. So we use equation of small k. Small k is called Coulomb constant, and its equation is 1 upon 4 pi epsilon 0, okay. In scalar form of Coulomb's law, we use this step, we explain this equation. So instead of k, use 1 upon 4 pi epsilon 0. So instead of k, here we have 1 upon 4 pi epsilon 0 into q upon r square as it is, into 4 pi r square as it is. Now here 4 pi will cancel out, r square will cancel out. So phi is equals to, our equation becomes q upon epsilon 0. Now here we have only single charge, that's why here we get q upon epsilon 0 is equals to 5. If we have more than one charge, okay, so we consider its sum, okay. So instead of q, generally we use sigma q upon epsilon 0. Sigma q represents sum of all charges enclosed by the sphere or enclosed by the closed surface. Now this is our equation of Gauss law, and last we have statement of Gauss law. Now statement of Gauss law, we have ratio of charge to epsilon 0 is equals to electric flux. So this is the simplest statement. Total electric flux linked with any closed surface means phi is equals to ratio of, okay, here we have ratio of net charge enclosed by surface. Net charge means sigma q, okay. Instead of q, here we use sigma q. So net charge enclosed by surface to epsilon 0, okay. So ratio of net charge enclosed by surface to epsilon 0 is equals to total electric flux linked with the closed surface. This statement is known as Gauss law, and this equations represent equation of Gauss law. Epsilon 0 is permittivity of free space. This is standard constant, and its value is 8.85 into 10 raised to minus 12 SI system, okay. So try to prepare this question. This is most important question of this chapter.